Hello everyone, this example we're going to discuss how to find the quotient and remainder for a polynomial, okay, using synthetic and long divisions. Okay, so suppose I give you this 5x to the fourth power plus x squared minus 8x plus 2 and divide that by x squared minus 3x plus 1. And I'm asking you to find the quotient and the remainder using the long and synthetic division. So let's use the long division first. So now we know that x squared minus 3x plus 1 is a divisor. So we're going to write that first. Okay. And in the dividend, we're going to have 5x to the fourth power. And notice that there's no term with the x to the third power, so we're just going to label it as plus 0x to the third power. Okay, always include it, even if it's not there. Use it as a 0 constant. And then plus x squared minus 8x plus 2. Okay, so let's see what is it going to give us. So first we divide the 5x to the fourth by the x squared. We get 5x squared, right? Because x to the fourth divided by x squared is x squared. Then we multiply it back with the divisor and we write out the term. So we're going to have 5x to the fourth, and then multiplying the 5x squared with a minus 3x gives us minus 15x to the third power, which makes sense because the powers decrease. Okay, and then plus 5x squared, right? We're just distributing the 5x squared to each of these terms in the divisor. Okay, plus 5x squared. So now what happens is you're going to subtract this result and you're going to have 0. And remember, you're subtracting this whole thing, not just the first term. So it's going to be 0 plus 15, right? So it's going to be plus 15x to the third power. And then x squared minus 5x squared gives you negative 4x squared. Okay? So now we're ready to further divide and see what we're going to get. Okay? So we're going to divide 15x to the third by x squared. So we're going to get plus 15x, and it makes sense that the powers decrease. Okay, we're going to multiply this 15x back with the divisor and write the result underneath. So we're going to have 15x to the third minus 45x squared, and then yeah, and that will be it. And let's see what we're gonna have. Actually, let's keep this 8x written here. And what are we gonna have for the last term? Plus 15x, right? Plus 15x. So as a result, we should have, let's see, if we subtract, we're going to have negative 4 plus 45. That gives us 41x squared. And then negative 8x minus 15x gives you negative, let's see, negative 8 minus 15, minus 20, minus 23, right? Okay, and let's copy this 2 again. the final number. So now we're still able to divide the 41x squared. So we divide it by x squared. We're going to get plus 41. Okay. Multiplying it back with the divisor, we get 41x squared. What is 41 times 3? That's 123. So minus 123x. And then plus 41. So again, we're going to subtract this whole thing. And we're going to get 0. Negative 23 plus 123, that's 100. And then 2 minus 41 is minus 39. Okay? So notice that we can't divide anymore. It's going to be the remainder because the power of x is 1 and the leading power of x in the divisor is 2. So we cannot divide anymore. It's going to be a proper fraction. So we leave it as a remainder. So the quotient is 5x squared plus 15x plus 41. And the remainder is going to be 100x minus 39. Okay, so now we're going to use unfortunately we can't use the synthetic division actually in this problem. We can use synthetic division, but we can use it if we factor the x squared. Let's try to factor. Let's try to factor x squared minus 3x plus 1. So if we factor it, factors of 1 whose sum is negative 3. Well, actually there are no such factors. Because if we take negative 1 and then minus 1 is negative 2, it's not going to be negative 3. So if it's not factorable, that means that the roots will be involving square roots. Okay, the solutions will require square roots. The factors will include square roots. So we can't factor it. But in any case, let me show you another example with which we can actually use the synthetic division. Let's see what we can do. Let's see. Okay. Well, let's just leave it this problem as a long division problem because this is a good problem to try to do by long division. And I'll discuss synthetic division in my next video. Okay?